Welcome to Geek Orthodox. I'm Father Justin, geek from my youth. The aspect of the world of code that I would like to speak about in this episode is what I'm calling embodiment. Computer code or computer programs obviously need to run on computers. And computers, therefore, computer hardware as we call it, is therefore the body that enables code to actually have an impact on the world around it, to actually exist, in fact, in the world. And therefore, the embodiment of code, the computer hardware that the code runs on, is determinative of code. It is a limiting factor. It is what shapes the code that we write, because the code needs to control a certain thing. So I'm using here as an analogy the body. If the spirit is that which we are essentially in our essence, it is our bodies that actually enable us to interact with and exist in the world around us. And so the analogy here probably isn't perfect, but I think it's actually a helpful one. Bringing up the subject of embodiment also naturally leads me, I really like the word why, to ask the question, well, why am I talking about this? Like, why me? And why am I using my old TRS-80 color computer as a platform to talk about this, to talk about the world of code? And I think there's a reasonably good answer here, which is why I'm doing this. This is obviously an old platform. I myself am getting old. In some respects, I and this computer represent a bridge from the world before code became all-encompassing and all-pervasive to the current world of code in which we live. I remember a time when neither I nor any of my friends and peers had computers in the home. There were computers, of course. Computers got started a fair bit earlier. My grandmother actually worked making punch cards for computers. That was how you input data into a computer back then. You actually punched holes in a card and sent it through a card reader, and she did that. But at those points, computers were these huge, relatively inaccessible mainframes that took up rooms and were not accessible outside of very limited conditions. It was really the first and second generation of the home computer revolution. This is a representation of the second generation of computers that came out at that point in time, that started to extend the world of code into the home, and by extension, and of course, and by extension, other aspects of our lives, including business, and so that it started to become ubiquitous. And so it seems to me that this is a good starting point, not only because it's simple, but because it actually represents the beginning of the world of code. Now, if we're going to talk about embodiment, we probably want to take apart the computer and look inside. And when we do, we'll see obviously a whole bunch of computer chips. The most important one is, of course, this one here. Well, not necessarily, of course. A lot of the others look fairly similar in this case. This is the most important one. It is in this case, the 6809E processor from Motorola. Other computers of this era used another very common and cheap chip called the Z80. And these inexpensive chips, computer chips, allowed for the home computer revolution to begin because, well, they were inexpensive, and you could then build a computer system that was reasonably functional, and that you could then sell to an individual in the home, and start to get this world of code extended. And it was fairly deliberate. There were people who, like Bill Gates, but others as well, who really wanted to ensure that there was a computer in every home. And so this inexpensive, or relatively inexpensive, computer revolution was this inexpensive body for code to be executed on, was what started to move code into our private lives, and started to make it ubiquitous. I also like this as a demonstration platform because I can take the code that ran on this TRS-80 color computer and now run it on this. So this is a Raspberry Pi Pico. It is not usually thought of now as a computer. It's a microcontroller, but it can be built into a computer. Now, computers, of course, aren't particularly useful if you don't have some form of input, or in this case the keyboard, and some form of output, in this case the graphics connector that connected it to my television set, my CRT television set. So in this case, while this is a chip, and you can see very clearly how miniaturization has played a huge role in making computers more powerful, more ubiquitous, the chip here by itself is not particularly useful. You need some form of output and or some form of input. So in this case, I've attached this same kind of computer chip to a screen, which has touchscreen input. I don't have power to it right now, but this is a touch screen. Given this now has input and output, but this then would be a very different platform than, I don't know, say this, where you have a screen and a keyboard, which is kind of the more classic way. But this is also now familiar to us with our phones. And so the different configuration of the computer actually makes a significant difference in terms of how we approach coding for the computer. If I have a keyboard, that then becomes a form of input that I can count on and rely on, and which there's what we would call a software stack that enables the computer to take input from the keyboard, and just like we saw in the program with INKEY string in BASIC, to register input from the computer keyboard more precisely, so that you can then use it to control the computer. Obviously, you also want to have some sort of output, which we saw in the basic print statement, that would display information on the screen. Or if we are limited by the fact that we have only a touch screen, maybe like on a phone, then we would need to find some other way of creating and receiving input from the user, and that would again require another whole bunch of code to do it. So if the computer on which we run the code is significant, in the sense that it changes what code we write, it changes how we interact with the computer that we're using, then what I've said previously about code being infinitely extensible is not 100% accurate by itself. Code is a virtual machine that is infinitely extensible in theory. In practice, you had various limitations, whether that be the speed of the chips that were available, the cost of the chips that are available, the complexity of the chips that are available, and of course all of the different input and output additions or peripherals that you then connect to the computer so that we can interact with it. So if we're going to talk about these limitations of embodiment and how they impact code and how code is structured and how code is implemented, then it's probably best to start at the most basic level, pun not intended, that is possible, which is to say the switch or the transistor, depending on how you want to describe it. Computers, as you probably know, are really just a bank of switches. But it's a little more complicated than that. They're a specific type of switch. They're an electronically controllable switch that allows us to create a bunch of circuits. And these circuits are structured as what are called logic gates. So if we go all the way down to the most basic level of the computer, we have a switch that turns on or off. This is why binary numbers, which are all a bunch of zeros and ones, are the fundamental language of computers. Zero can represent off, one can represent on. But we want more than just a bunch of switches that turn things on and off. We want a bunch of switches that can actually make decisions, or rather implement decisions. We're the ones making the decisions. And so as we get to the most basic level of the computer, you need this logic gate. And there are various types of logic gates. I won't go into all the different types. What's more important for our purposes is that these logic gates can be arranged in more complex and more complex and more complex configurations that then allow us to, as we structure them in such a way that we can then control things with them, allow us to then control those logic gates with further layers, which I would call computer code. And these layers of computer code that control the logic gates are themselves arranged in ways that are more and more extensible, more and more complex. This is why I would say there is no theoretical limit to the extensibility of this kind of machine. Whether there is a physical limit, the limitation of embodiment, but theoretically, as we go on, we can simply add more and more and more logic gates to give more and more and more capacity, which allows us to have more and more and more complex code running on these devices. So if we're going to understand this world of code and how it operates, we need to begin then by understanding the computer. And the essential aspects of the computer that we've covered so far are you need input. You need some way to put information into the computer so that you can control it. That would include code. You need output. You need some way of getting information out of the computer, displaying it so that what it does internally is useful. But between input and output, you have the logic gates that are contained in the central processing unit. That is the brain of the computer. And the central processing unit is what executes the commands that we give it via code and stores information and processes information in the memory. So with this, then, we have all of the essential components of the computing platform that we currently use. Input, output, processing, memory, and the sequence that can not only repeat things, but do so conditionally. And with this, we now have all of the components of the world of code that we interact with, and we can start to think about how this setup, this process, affects us as we use it. Because that's really, for us as human beings, the most important aspect of computing. Not the fact that we can do more. That's pretty much the basis of all technology. It allows us to do more things more strongly, more quickly, and whether that be an axe or a chainsaw or a light switch or a whole series of switches inside a computer. All of those various forms of technology just allow us as human beings to do what we do, what we choose to do, more quickly, more easily, more powerfully, and possibly move, if you will, our presence from one place to another. The tools and the technology that we use as human beings tend to define us, tend to define how we interact with the world around us, tend to define what our capabilities are as we interact with the world around us. And so they allow us to do certain things that well and easily and without too much extra thought once we have mastered the technology. But they also limit us in ways that perhaps we don't think about. And my hope is that as we engage with this world of code, think about both how it's embodied, how it is structured, what it is good at, and what perhaps it's less good at, that we can then engage with the world of code as we need to do as inhabitants of this world in a way that is thoughtful and intentional, where we think about what we intend to do with the technology that we choose to use and how choosing this technology will help and possibly also hinder what we intend. Some of the implications of the world of code and its embodiment we've already touched on. And I would like to, with the foundation that we now have, look at those aspects in a little more detail in future episodes of the world of code. The digital nature of the world of code. The fact that information is represented in zeros and ones instead of in the more traditional analog ways. That impacts us and our engagement with the world around us as we utilize the world of code. The quirkiness of the world of code, the fact that technology takes all sorts of different forms and shapes, even in terms of different computers and computing platforms. This too is something that we should be aware of and consider as we engage in and use the world of code. The complexity, the ever-increasing complexity, as we deploy code in more situations, as the platforms that we use become more and more complex, as there's this continual back and forth between increasing power and complexity and simplification and abstraction, leading to more increase in power and complexity, leading to more need for simplification and abstraction. This continual process is another thing that has and continues to shape our world of code. And as inhabitants of the world of code, we can be active or passive participants. We can be aware or, largely unaware of how the world of code in which we live and move and breathe and have our being impacts us and impacts the world around us. My hope for this arc of the podcast is that as we continue to explore these questions based on this foundational understanding of the hardware and the software, the physical embodiment and the spiritual expression of the world of code, that as we do this, we will be not only better informed, but better equipped to choose how we engage in it, how we use it, and what we do with it for the betterment of ourselves and the world around us.